Welcome to chapter 14.3, Pure 1, where after introduction of the exponential number e, now we're looking into the modeling. So, notes. Linear model is good at representing direct proportional relationship between two variables. However, in some real life situations, some variables increase or decrease much more vigorously. For example, the growth of bacteria over time or the decay of radioactive particles over time. So we know the amount of bacteria doesn't grow by the same amount every second or every certain time period, right? It grows rapidly. It compounds every other second or after every milliseconds, if you think about it that way, like our cells in the brain or in the body. So let's say we have 2 milligrams of bacteria and it grows by 10% per second. Then the multiplier, because 10% is 1.1. That means after 1 second, you will do 2 times 1.1. That will be 2 times 1.1 milligram of bacteria. After 2 seconds, it will be the first second, 2 times 1.1 times another 1.1, which is same as 2 times 1.1 squared. The third second, it will be 2 times 1.1 times 1.1. Actually, I made a typo in here. You should be aware that you should know there should also be a 1 times 1.1. So that's 2 times 1.1 cubed milligram of bacteria. Now, in summary, we can represent this as an exponential model because you can see the number 1, 2, 3, the variable time is actually on the power. So we can write as P, the bacteria, equals to 2 times 1.1 to the power of T. More generally, we can write as P equals AB to the power of T, where A is the initial value. Okay? Right. So let's move on to this one example. The density of the pesticide is given in a given section of field, where this time is P, can be modeled by the equation P equals 160 e to the power of negative 0.006 t, where t is the time in days since the pesticide was first applied. Use the module to estimate the density of the pesticide after 15 days. Now, from this equation, can you tell me how many variables are there in this equation? 1, 2, or 3? There are 3 letters, but there are 2 variables. The variables are P and T. Okay? E is just a 2.718, etc. It's like pi. So, question A, if I want to estimate density, so in P and T, the variables are P and T. If I want to work out P, then surely I must know T. Indeed, 15 days means T is 15. So I can relate. So when T equals 15, the question is trying to tell me when T is 15. So I'll substitute into it. So P equals 160 e to the power of negative 0.006 times 15. Okay. You should be able to find where the E button is. The E button should be somewhere on the top, next to log or next to a power function. You should see E to the power of something. Let me show you on my calculator. So on my calculator, just make sure. Yep. On my calculator, the E function is here. Shift ln. So you can see this is ln, but it's not in, it's not in, it's L, it's an L, ln. So in here I'll put 160. Oops. 160 e to the power of negative 0.006 times 15. And I got 146. So P equals 146 milligram per meter squared. Okay. Question B, interpret the meaning of 160. So if you compare this 160, this is the value of A, like the previous one here, and which represents the initial value. Now, why is it initial value? Because when T is 0, okay, so now this is not required in the answer. When T is 0, we know P equals 160 e to the power of negative 0.006 times 0, which give us 160. That's why when P is 160, so 160 is the initial, copy the question, initial density of pesticide given in a given section of field. Okay, so that's the answer we're looking for. The main word is initial. Okay, the keyword is initial. Part C, show that dp by dt equals kp, where k is a constant and state the value of k. So I want to find dp by dt. So p equals 160 e to the power of negative 0.006 t, right? So let's do dp by dt, what the question suggests. Will it differentiate? To differentiate, e will multiply by the coefficient of t. So it'll be 160 times negative 0.006 times e, and the power remains unchanged. Hopefully you do remember, if you struggle to understand this, let's say in here, for example, let's say y equals 5e to the power of 4x. To differentiate, you would do 5 times 4e to the power of 4x. You multiply by the coefficient of x, but the power of e remains unchanged. That's what I did in here. Just multiply by negative 0.006. Okay, put in a calculator. 160 times negative 0.006, you should get negative 0.96 e to the power of negative 0.006 t. That's dp by dt. Now the question wants to ask you, okay, that should equals to kp. So therefore, negative 0.96 e to the power of negative 0.006 t should equals to kp. Well, what's p? P was 160 e to the power, right? That's p. So left hand side, I rewrite it the same thing. Okay. So I want to work out the value of k. Well, simple. In here, I can see both sides e. Same thing. I could divide both sides by that. And then therefore k will equal to negative 0.96 divided by 160, which is value of k. And if you put in a calculator, incidentally, k actually equals negative 0.006. All right. So that's the answer. Part D. That's really a question. Interpret the significance of the sign of your answer to part C. So what's the sign? The sign is, ask me to do more maths. No, the sign is negative. Okay, so the sign is negative. So what is negative here means? Okay, let's rewrite that. So part D. Okay, so essentially from C, what we know is we know dp by dt equals to negative 0.006p. So they're asked about the sign. Now, before we do that, let's think about what does dp and dt stand for? dp and dt stand for the rate of change, right, of p over t. It's like, you remember with dy by dx is the rate of change. It measures the rate of change. Okay, if it's a negative, negative means it's a negative rate of change. So it's a negative rate. So the negative sign in C represents a negative rate of change of, what is P? P is a density of pesticide, can't spell, pesticide applied over time, over every day, over days, over days. Oops, why is my pen not working? Days. Okay. In other words, to write a bit better, okay, to write better, this is good enough, but to write better, we can say the density, oops, of pesticide given decreases every day. Exponentially. Well, why is that the case? That means initially I give it, that means initially, is it 160? Sorry. Yeah, in a given, the density rate, not density given, sorry. Density of pesticide decrease, not given, sorry, not applied, sorry. Because initially we've got 160, right? And then what it means is after 15 days, you've got 146. So you can see the negative means every day the amount of that pesticide inside the field is decreasing. Maybe if it has evaporated, maybe some of the bugs or some of the things, some of the things eaten, has eaten the pesticide, has swallowed the pesticide or digested, or it got absorbed by the soil, whatever. So it just means the density decreases every day, okay, exponentially. So question E, sketch a graph of P against T. So sketch a graph of P against T. So question E, okay, so let me write again. P equals 160 e to the power of negative 0.006 t. So sketch a graph of P against T. That's P and that's T. Now, let's think about this. Okay. So what's the parent function again? So we know the shape, okay, so the shape is e to the power of negative 0.006 t. That means the shape is going to be look like this, right? Okay. And then 160. So when x equals 0, then when t equals 0 rather, when t equals 0, p will equals to 160 e to the power of 0, which is 160. Okay, so this is what the graph looks like. Now, normally that means this is 160 in here. So we have the graph like this, but we know t cannot be negative, time cannot be negative, so therefore we have to rub off the negative part. So we can't have any negative part of the t. The graph looks like this. That's the answer. That's the graph. And that's the graph. Okay, asymptote at p equals 0. Right? So quite a bit of to absorb in here, modeling. I've given you a similar question. You can have a go at the next question. Okay, have a go. Okay, pause video, have a read through. Okay, when you are ready for the answer, you can press play. Here are the answers. Okay, if you got it right, well done, move on. That's the end of lesson for you. Okay, if you don't, we'll go through, okay, one by one. Question A. So we got P equals E to the power of negative 0.13 H. So we want to work out the pressure. Pressure means P when the altitude is 4.394. We know altitude is the H value. So question A, we sub in H equals, so when H equals 4.394, then P equals to E to the power of 0.13 times 4.394. Put in a calculator, you will get, not hours, sorry. I don't know why I put hours in there. Bars. Oops. Bars. So you should get, put in there, you should get 0.565 bars. That's the answer. Okay. Question B. Show that dp by dh equals kp. So same thing. We do dp by dh. Let's differentiate p with regards to h. So multiply by the coefficient, which is negative 0.13 e to the power of negative 0.13 h. Power remains unchanged. And we know now negative 0.13 e to the power of negative 0.13 h equals to kp. What is p? P is e to the power of negative 0.13 h equals negative 0.13 e to the power of negative 0.13 h. So what we can do in here is we can then cancel this two out. So therefore k is indeed negative 0.13. Okay, part C. I've shown you the answer. It's a negative. Again, it's a negative. So negative 0.13. Sorry, k is negative. Negative again. Negative shows you that the rate of change is negative. It means the atmospheric pressure decreases exponentially over the climbing altitude. That means as the altitude goes up, the pressure actually decreases. Question D. This model predicts that the atmospheric pressure changes by s% for every kilometer gained in height. Calculate the value of s. Sounds difficult, isn't it? But what it wants you to do is they just want you to calculate the difference in the pressure when the height increases by 1. So what you can do is work out the p-value when h equals 1 and work out the p-value when h equals 2 and do the difference in percentages. So when h equals 1, put in the calculator. So when I put in a calculator h equals 1 and put it into back to original, I get p equals that one and that one. So to work out the percentage change, I can just do 0.771015 minus 0.8780954 over the original. 0.87800954 times by 100. You should get 12%, hopefully. Yeah, I got negative 12%, which is, that's correct. Okay. And that's the end of exponential modeling.